Okay, this is chapter 13, page 2 of notes. We've been talking about 4 principles of experimental design, control, and randomization. Step 3, or the third principle of experimental design, is replication. Replication simply refers to the practice of repeating the experiment on a number of subjects to provide enough data to assess the variation from subject to subject, or the response variables from your study. Also, replication supports the concept of having a good representative sample of data. So you want to be able to repeat or replicate the experiment over and over again to give you new data, new results to analyze. The fourth part of the study is called blocking. And basically, with blocking, it is sometimes needed, it's not always needed, but sometimes you might have attributes of a subject that aren't really meant to be part of the study, or you want to exclude them from being part of the, or influencing the results of the study. So sometimes these attributes that are not part of the study may affect the outcome or your response variables of an experiment. Blocking basically refers to the process of grouping similar subjects first based on whatever attribute is the same, grouping those subjects first, then randomize within each group or block. So the groupings that you divide your subjects into would actually be called blocks, and then you would include your randomization element within each block. Blocking is not a requirement of a study. Depending on what's going on in your study, will determine whether or not blocking is something that's needed. So when we're doing experiments, we're going to be basically diagramming them. And this is a initial diagram. Gives you the basic idea, but it's a very simple version. We'll get into more sophisticated versions tomorrow. But we'll start with a group of subjects here, actually. And then these subjects, you would randomly allocate them to however many number of groups you have in your study. So in this study, we would have 2 groups. So we would take all these subjects, randomly assign them to group 1 or group 2. Group 1 would have some treatment associated with it. So group 1 goes with treatment 1. Group 2 has a different treatment applied to it. So in this particular study, there's 2 treatment levels that are being looked at. So 2 groups are all that are needed. And then at the end of the study, after the treatment has been applied, you compare the response variables. Across the different treatments. The idea here is we're looking to compare what is the different effects of these 2 different treatment levels. So we'll compare and check out our results. So that's a simple design. We'll modify or expand from that simple setup. Some more vocab. What is the definition of statistically significant? We're trying to, the purpose of any survey or any study is to decide if there is any statistical significance in some answers or observations that we have. So the definition we want to use here is statistically significant is when an observation, an observed difference is larger than what we would expect by chance only. We know there's chance variation in everything. Statistically significant difference would be a difference in a response variable or in a result that's bigger than what we would anticipate. So this is what we're looking for in any study. What's a control group? A control group is a group within your study. Say maybe you might have actually 3 groups here. A control group in the study is a group that has no treatment applied. So you could have treatment 1, treatment 2, and then no treatment to control and see, well, what happens if you do nothing? Or what are the responses if you apply no treatment, do nothing to the subject? This basically provides, in an experiment, it provides like a baseline measurement. What happens if you don't apply any changes to your subjects? That's kind of an important piece to have. Closely related to that is this term called a placebo. I'm sure you've heard about it before. A placebo is an inert treatment that looks like the real thing, but it's not. Say in the case of a medical study, you may have groups that get different levels of a new drug, different number of milligrams of a new drug, and then you might have a control group in your experiment that still gets a pill to take, but it has no active ingredients in it. And you've probably heard it called the sugar pill. So it looks like they're receiving a treatment just like everybody else in the experiment, but the treatment should have no effect. There's a thing called a placebo effect, where even if people think they're receiving some treatment, they could have some physical response, even though they are really just receiving a placebo. So the mind is a powerful thing. Our last vocabulary word on this page is blinding. And blinding is when some of the people involved are prevented from knowing information that could lead to bias in your study. It's kind of related to a placebo thing, but it goes beyond that. You might want your subjects to not know what level of treatment they're receiving. That would be the case of a single blind study, where one group is blinded, say like your subjects are blinded from knowing what treatment level they're receiving. A double-blind study would be where both groups are blinded, and what I mean about both groups would be this. In an example of a medical study, the subjects would be blinded from knowing what treatment levels were received or what medication levels were received. But in addition to that, the physician would also not know what treatment level they've received. And this way you get an unbiased reports from the physician. You get unbiased reports from the subjects about how they're doing. They don't know if they've been receiving any treatment or a little bit of treatment or a lot of treatment in terms of the drug dosage. Okay, we're going to stop here for this video. And we'll resume our note-taking with page 3 next time.